is recording now, I think. Yep, it is. All right. All right, so now that it's recording, we'll go ahead and fix the program first, okay? Because, the program did not work, and, I really want to fix it, okay? So the question now is, how am I going to fix this program? And let's see, that is in another terminal, which is here. All right, so this is the program that I want to fix first, okay? The first thing is, I only want to add 1 to x when scanf returns a 0 or 1, but if it returns anything other than a 0 or 1, I just want to say, oh, okay, it should not affect x, okay? That's what I want to do. All right. Now, there are 2 ways to go about doing this. One is scanf can only return a 0, cannot even return a 0 in this case, okay? Because the only time you cannot read something as a character is there's nothing to read. But if there's nothing to read, it's also in a file, which means scanf should return EOF, which is the same thing as -1. So there are 2 ways to go about doing this. You can always just do it the easy way, which means that if scanf is greater than 0, then go ahead and specify a value of 1. Otherwise, you specify a value of 0. I'm using a ternary operator here to basically say if scanf is returning anything like 0 or less, okay, don't change x in any way. Only add 1 to x when scanf returns a 1 or any positive number. But we know it cannot be returning 2 because I only asked for 1 single character. So this will fix the problem. Go ahead.
Could you just put it back to the x++ afterward to fix that problem as well?
That won't work because that will actually, it will add 1 character more than it should. Because the last scanf is going to fail, but x++ is going to keep adding anyway. So it will report 1 character more than it should in that case. That's a good question, but it's not going to work because the last scanf is not actually reading back anything. So this will fix the problem, and just to be sure this is in fact fixing the problem, I'm going to recompile the program, relink it, and then run it again, and we'll put a breakpoint on the last line. So we'll put a breakpoint on line 13 in this case, because I'm pretty sure this is going to work the way it's supposed to. So we'll run it, redirecting the input from test2.in, which only has 4 characters, and x is now exactly 4. So that kind of fixed the problem. Okay. Are there any questions about this? So the next thing I want to do, as I said a little bit earlier, is to illustrate the concept of an address of a variable as opposed to the value of a variable using GDB, which is the perfect time to do it now. Because I can print x, I can print ch, and they're basically it's just printing the current value of those 2 variables. X is an integer, that's why when I print it, it prints as an integer, and ch is a character, so that's why when I print it, it reports back both the integer value, which is the ASCII code, but also the interpretation of that ASCII code. In this case, the ASCII code 10 is representing the line feed character, but since the line feed character by itself cannot be printed, it's a non-printable character, so it uses \n as a way to represent the line feed character. Are there any questions about the value of a variable? Okay, if there are no questions about the value of a variable, we can now say, okay, give me the address of x. Oh, that's a chunk of gibberish here, right? Because 0x meaning it is a base 16 number, BFFF9, 9C in this case, is the address of my local variable x. Well, what does it mean? I mean, this doesn't look like an address to me. I mean, 4700 College Oak Drive, Sacramento, CA 95841 is the address of ARC. That doesn't look like an address to me. How do you think bytes inside the computer is organized? The memory. Well, first of all, does everybody understand what is the concept of computer memory, RAM, in the context of a computer? Okay, that's what your program uses to store both the program in execution as well as all the variables, local or global. They're all stored in memory. So now the question is, how do I, what is an address of a single byte within the memory of a computer? Okay, I'll give you two choices. Okay, do you think it makes more sense to store in the usual way, like street number, street, city, state, and a zip code, or does it make more sense to store it just like a number? Because all I need is to differentiate the one location from another location. First one or the second one? Just the number, exactly. So consider this one huge long main street where you have location 0, which is the first byte of the entire street, the first house of the entire street, to the highest location that is possible. Okay. Now I'm gonna shortcut a little bit here and not talk about virtual memory versus real memory and stuff like that. But as far as your program is concerned, it is just a huge number. Okay. So think of your computer memory like this. It's just a whole lot of bytes. Okay, so each cell is basically a byte. Okay, and the first byte starts at location 0. Okay, because in computer science we like to count from 0 and not from 1. So the first location is 0, and the last one is up to the operating system. So depending on the operating system, it might give you a different maximum address. But nonetheless, what is the location next to the 0? Location 1. And what is after location 1? Location 2, and so on. Okay, there we go. So each byte in memory has one address or location associated with it. And to differentiate one location from another location, it's just a different number. Okay, but that number is sequential. Okay, it is sequential. There are chunks of memory that is not really addressable by your program. So they do come in chunks, okay, and there are certain locations that your program cannot access. But that makes this really just a long number. Okay, yes, if you convert it into base 10, this is a pretty big number. But nonetheless, it is just a number, an integer, to identify that single location from all other locations. That is the address of a variable. Okay. Well, since we can tell the address of x, we can also now tell the address of ch, which is another variable. And you can see the address of ch is pretty close to the address of x. It's just off by 1 byte. In fact, which one has the lower address? Which one is before which other one? ch is before x. Yep, that's right, because b is before c. So without even converting these numbers into base 10, we can quite easily tell the ordering of the addresses. Are there any questions about the address versus the value at an address, or the content of an address? So the content of this address is the value 4. The content of this address is the ASCII code 10, or if you will, 0000 1010 in binary. So are there any questions about address versus content? No questions so far? Okay. So at this point, we're not going to talk too much about address versus content. There will be another topic where we focus on just the address of something. And as it turns out, this is both a really powerful and flexible feature of C and C++, but if you use it incorrectly, it can also cause a whole lot of problems, much more so than any other programming language. So when you use pointers, you have to be careful. All right, so if there are no questions about this, we'll kind of go back and kind of test some more code here. In fact, what I'll do is I'm going to write this code here. Okay, I'm going to write this code, and I'll test it with a few sample inputs just to see what we're going to get. Okay. All right. So let's go ahead and write that program exactly. So I'm going to say vim, give it a name, scanfs.cpp. Okay, we we have one integer type x, we have one character type ch, which is kind of like a long integer, a shorter integer, but it also has a kind of special purpose to it. And then we have an integer y to store the return value of scanf. So we'll have y equals scanf. I'm going to do exactly what I said in class a little bit earlier. I'll just read an integer in base 10 into x, or attempt to anyway, and then store a character after that into ch, and do a return 0 here. In fact, I'm going to do a z here, so we can just run the code. At the end, we can then compare what is y, what is z, what is x, and what is ch. All right, so this is my program, g++-g-c-wall, cpp. All right, it's complaining about the same thing for both variables because we set a value, but we didn't quite use it later on, but that's okay. We'll now link the program to scanfs, and the source file, or the object file is scanfs.o, gdb scanfs, list the program, okay, nothing special, breakpoint on line 11. So we'll run both scanf, as if there's nothing in between. We'll now run the program. We'll go ahead and try 1, 2, 3x first. 1, 2, 3x, like that. What do you think should be in x, and what do you think should be in ch? Let's start with x. 123, right? Because it will interpret the digits 1, 2, and 3 into the value of 123. Store that into x, because we pass the address of x to scanf, and that's where it will be stored. And what should be in ch? The letter x, or the ASCII code of x, should be stored in ch. Okay, so we'll go ahead and press the enter key. Now we're done with both scanf operations. Oh, by the way, what should be in y? 1. And what should be in z? 1. Okay, and we said 123 should be in x, and we said x, or the ASCII code of x, should be in ch. That's all correct. Okay, very good. Let's run the program again. This time we'll try something a little bit funky. We'll have x1, 2, 3 in this case. Okay, so we'll start with x and then 1, 2, 3 after that. Okay, so in this case, what do you think should be in x? Garbage, because we could not interpret the letter x as an integer. So as a result, the first scanf is going to fail, which also means y is going to be 0. Now, what about the second scanf? Let me just list the program again. What about the second scanf on line 10? What am I reading into ch? Well, if you fail to interpret x as the beginning of an integer, it does not move. In other words, the conveyor belt does not move until you take away an item using scanf. So if your instruction is to remove a blue box from the conveyor belt, and all you can see at the front of the conveyor belt is a red box, you don't automatically get rid of the red box. You just say, oh, I don't know what to do with this. I'm not removing anything from the conveyor belt. That's what's happening here. Because scanf is told to read an integer. It could not read x as an integer, and as a result, it did not touch it at all. So when we attempt to read a character, then it would go ahead and say, oh, okay, x is the character that it's reading. This is how you recover from an error. Because if you cannot interpret the input as an integer, it has to be some non-digit thing, right? It can be a punctuation, can be a letter, can be anything that cannot start an integer. So you use line 10 as a mechanism to clear away whatever is obstructing the way, so that you can continue. Okay. So we'll go ahead and print y, which is a 0. Z is going to be a 1 because we did successfully read a single character. X is uninitialized because we could not read anything into the integer. And then ch is x in this case because the first scanf on line 9 did not process anything at all. Okay, it took a look at the front of the conveyor belt and said, hey, this is not the beginning of an integer, I'm not going to touch it. So X is still on the conveyor belt by the time we get to line 10, then it will just read it and go like, oh, okay, here's a character, I'm just going to take it away. Yep.
So if we had this like in a loop, then since we've taken X out now, it would go back and we could
Yep.
take up the one.
Well, you need not just one loop, you need kind of like a kind of special kind of loop. Let me see, is one loop going to be enough? Yeah, one loop is enough. One level of loop in readnum is going to be enough. But you kind of have to decide, what the loop has and what is the condition to get out of the loop. But you can give yourself several scenarios to kind of play with it, and then you can say, oh, okay, so with this scenario, how many, do I have to go through the loop a few times? So here are also a few scenarios that you might want to go through. The first one is just 1, 2, 3, by itself, okay? So if you have 1, 2, 3 all by itself in an input file, obviously, it doesn't have to go through the loop many times. The second one is x 1, 2, 3. In other words, you have one thing that is obstructing from reading the integer, so you have to clear the x away, and then you can read 1, 2, 3. So in this case, whether you have a loop or not doesn't really matter, because you just need a quote-unquote conditional statement to do it. But what if you have x, y, 1, 2, 3? What if you have x, y, z, 1, 2, 3? So these are the test cases that might help you think about the control structure of the loop. Okay.
And how about something like X 1, 2, 3, Y?
X 1, 2, 3, y is an interesting one because x 1, 2, 3, y means the first call to readnum will process this much because it will read 1, 2, 3 as 123. And as soon as this is processed, as soon as scanf with %d as a format string is successful, you're done with this particular call to scanf. Is that okay? But when you're done with reading 1, 2, 3, this is going to be the next character to read for the next invocation of readnum. So now it all depends on, is this it? I mean, if this is the end of the file, then it will fail because there's nothing else to read after this. On the other hand, if you have more numbers like 200 over that, then the second call to readnum will throw away the y. It will first encounter an error, then you will have to throw away the y and then read 200 as 200. Okay. Any questions? What if I flip the order of the two scanfs and see, let's see what happens when I flip the order. So we'll quit this and we'll go back to this one. And this time I'm just flipping the order of the two scanfs. And then we go back into the program, relist everything, and run it again. But this time it's a little bit tricky, because what if I just specify 1, 2, 3, and then press the enter key? I need to put a breakpoint on line 11 first, run it again, 1, 2, 3, press the enter key. Okay, so now what do you think Z should be? On line 9, scanf is saying, give me one character. I'm going to take one character and store that into CH as a local variable. So at that point, the conveyor belt has the digit 1, right, as the first character. So do you think that scanf is going to be successful? Yeah, it will read the digit 1 and put it into CH. And then by the time we get to line 10, what else is on the conveyor belt? 2, 3, exactly. So we'll read 2, 3 as 23, store 23 as a value into X. So in this case, Z is going to be 1 because we did read one character. Y is going to be 1 because we also read an integer, but it's not what most people expected. Okay, so let's double check. Z is 1, Y is 1. So both scanf read one single item. They were both successful. CH is not 1. It is the ASCII code of 1. On the other hand, X is 23, as in just the value of 23. Are there any questions about this particular run of the program?
So you're saying that Z is first, right? Looking for a character. Is that
Say
right?
again?
On line 9 above there.
Uh-huh.
We have C equals scanf, and then we have C.
We have-
C. So it's waiting for a character, right? First.
Right,
And then we give it 1, 2, 3.
right.
And then how does that find a character that's a digit first?
Any digit is a character. 1 is a character, 2 is a character, 3 is a character.
Oh.
Anything you can type on the keyboard is a character. So that's what I'm trying to illustrate here. Is 1, 2, 3 is just 3 individual characters. Now we look at it, eyeball algorithm tells us it's 123, it's one piece, but because I'm using a scanf that's only reading a character, it would just take the first character out of the 3 and say, okay, you asked me to read a character, here's a character. But then by the time you get to the second scanf, which is the one that is supposed to read an integer, we only have 2, 3 left as the characters, and that's why it will only read back 23 as a value. Okay. Well, let's do something else. Let's run this program again, and this time we'll give it 1, 1, which is even more clear as to what the program is doing. Both read operations were successful because Z and Y are both 1s. What we read into CH is the character of 1, which has an ASCII code of 49. What we read into X as an integer is the value 1, because I'm interpreting the letter 1, the digit 1, as value 1 in this case. Are we still doing okay so far with this? Okay. Just to be sure, let's run it again. This time I'll have 1, 0, 0, 0, 0, 0, 1. Okay? What is it going to give me? Same result as last time, right? Because the first read operation is taking care of this character here. It will read it in as a single character, so CH is going to be the ASCII code of 1, which is 49. After that, the second scanf is going to take this bunch and say, I'll read this in as one single integer. Well, but that's just a long way of spelling out 1 in base 10, right? So that's why 1 will also be stored into variable X in this case, despite we have a whole lot of leading zeros. So let's double check. Z is 1, Y is 1, CH is still just the ASCII code of 1, and X is still just the value of 1. Is that okay? Okay, so you kind of have to make sure that the ordering of reading a character and reading an integer is interleaved in a correct way in your code. The first thing you want to read is what? The first attempt to read in read num. Is it going to be an integer using %d, or is it a character using %c? You always try to read an integer first, okay? Because if it's successful, you're done. You don't want to do anything else. On the other hand, if you attempt to read an integer and it fails, then you have to go back and say, how is it failing? Now, if it fails because it has hit end of file, which means there's nothing else to read, scanf returns EOF or -1, then there's nothing you can do, okay? You don't even have to attempt to read a character anymore because there's nothing left in the input file. You can just go back and say, whatever, okay? You can return whatever value you want in that case. But if scanf returns a 0 instead of a -1, it means you ask me to read an integer, but I encounter something that cannot be interpreted as an integer. Then you have to read a character to clear that non-digit character away, and then re-attempt to read it as an integer again. But you might have to do it a few times, because if you use x, y, z, 1, 2, 3 as the input, this is going to be processed by a single invocation of renum. Okay, but it has to go through one iteration, two iterations, three iterations, and then this one, I'm not sure whether you count it as a fourth iteration or not. The fourth attempt will actually read back a number as a base 10 number, and then you will say, okay, now I got what I want, and then it's time to return. Are we still doing okay so far with this? Are there any questions? Any questions about the homework assignment or the topics that we have talked about today?
Okay, something about the check-copies. For example, is we use a homework assignment in Java, okay, find factor. So we give it a number and give us a factor back. So what does this program do? We give the number and give us the integer back?
Not in the form of a parameter. When you look at readnum, it has no parameter. So what it is reading from is standard input file. So in readnum, you have to call scanf. That's how the input is coming in. And then you can use the redirect operation so that you can prepare a whole bunch of test input files so you can cover all the kind of tricky cases. Okay, I'll give you another tricky case here. Okay, so just interpret this line here. Okay, there may be more stuff after this. There may not be any more stuff after that. But just look at this line here. How many readnums should you call? How many invocations of readnum will this process? Will process this entire line? Three. That's right. Okay. The first one will be easy because it's just 1, 2. But after reading the 1, 2, it will leave the conveyor belt at X. So the second call is going to process X first. It's not a number. Clear that away. It will process Y, not a number either. Then it will process 2, 3 as an integer. The decimal point is not a part of an integer, so it will stop right here at the end of the second invocation. Okay? The third invocation is going to start with the period. And it will try to interpret the period as the beginning of an integer, which is going to fail. So it will skip this, okay? You will take it away using a scanf using %C, and then we'll go to the 4, 5. So it will process 4, 5, and it will stop at the line feed character. So that's why this will take 3 readnums. The first one will return 12, the second one returns 23, and the third one returns 45. So these are the kind of things that you want to specify in your test file just to make sure that it covers all the cases. Yep.
So our program just should, in this instance, should return 1, 2, 2, 3, 4, 5 to X, like a whole string of numbers.
The program itself, the main function itself is going to call readnum repeatedly as long as it is not in a file. So it will come back and print 1, 2 with a line feed. It will print 23 with a line feed, and it will print 45 with a line feed. That's the output of the program. And you don't want to alter the output of the program because the script that I write will automatically cross-check the output of your program with the expected output of the program itself. So you don't want to insert any additional messages when you're done, when you turn in the homework. If you want to use printf for debugging purposes, by all means, but you want to take out those extra printfs by the time you turn it in. What if I give the entire program an empty file? Okay, let's take a look at the code of your homework assignment, the part that is given to you, and then you can tell me what is going to be the output when the input is an empty file. In other words, you run the program and then you type Control D right away. Without typing anything else, you just say Control D, I'm done. So when you look at this code, what is it going to do? Well, first it will go to the do loop here, but the do loop is a post-checking loop, which means we're going to go into the body of the loop and perform line 12 first. Line 12 is going to call your subroutine read num, right? And in your subroutine read num, it will attempt to read an integer first, which will fail. But the way it fails is not returning a 0, which means I read something, there's something in the file, but it's not what I'm expecting. It's going to return a -1 because it's already in a file. There's nothing in this file. It's going to return -1. So read num is going to come back and say, I couldn't read anything, X is meaningless. But at the same time, we are in a file. So that means on line 13, and a file is true, not true is false. So what if the condition of an if is false? You go to the else or you get out completely. If there's an else, you go to the else. If there's no else, you get out completely. In this case, there's no else. So that means we get out of the conditional statement altogether. Then we get to the while part of the do while loop, which is basically saying, should we go back and do it again? We will only do again if the condition is true. Once again, FEOF is returning true, not true is false. So the condition of while is false, which means we exit right away. There's no output whatsoever when the input file is empty. Is that okay? So an empty file is a special case that you should also use to test your program, because your program should not have any output whatsoever when the input file itself is completely empty. Now, what if it's not completely empty? It's just ABC and then the line feed character. The output should still be empty, because in that case, if the only content of the file is ABC and then the line feed character and then EOF end of file after that, the first call to read num is going to say, okay, let's start with A here. That's not the beginning of a number. 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 Oops. Scanf returns -1. End of file. I have to get back anyway. There's nothing else to process. So read num will come back with some gibberish. Okay, you don't have to worry about what gibberish to return. But by the time you get back on line 12, it is already in a file. So the same thing happens as last time. Because it's in a file, you're not going to print anything here. You will also exit the loop after the conditional statement. So that's a special case. Okay, those are all special cases. Having just ABC and the line feed in the test file, and empty test file, those are special cases. But you have to make sure your program does work correctly with those special cases. It's always the special cases that makes a program difficult to write, because you have to make sure it works for all those cases. And then this program, it seems easy, right? All we want to do is to read an integer, but because of the error checking and the error processing, it makes it harder. Most people think that error checking, especially to deal with user errors, would easily increase a program by 100% in terms of number of lines. Because how many ways can things go wrong? Many. How many ways can things go right? One. So there you go. It's just like telling someone direction to go to some place. Every single time there's a turn, there's always an opportunity that person can make a mistake. And it's the same way with processing input. Yep.
Is negative read as part of the integer?
Yes, negative can start a number. So that means if you have the input like like that, it will process from the negative all the way to the 3. So assuming this is a line feed here, it will process 1, 2, 3, 4 characters to represent -123, and then it will stop at the line feed character for the next read num. Now read num is, scanf is interesting because if this is a line feed or empty space, scanf will automatically skip all that stuff. So you don't have to kind of do special processing with line feed or empty spaces. Are there any other questions? Because this program does have more complexity than all of the programs that we have done before. So if you kind of have to think it through, make sure you understand what the subroutine is supposed to do first before you start coding. That is the most important part. So run through all the kind of scenarios and make sure that you understand what the program is supposed to do. Not really necessarily how to do it, especially in C code, but you got to think about what it is supposed to do first. Yep.
Will read num return a value to me?
Will it return a value to main? That's what it's supposed to do on line 12. So on line 12, you call read num. Whatever value you return is going to be stored in X, which means you have to have a return statement in read num. It is not in the template, okay? So you gotta remember to put it there. Any other questions? Okay, do you guys not have any questions, or are you just kind of let it soaking? Are you letting it soak for a while at this point?
I am
Processing. Okay, that's good. It does require a little bit of processing, so don't try to rush through this one. But I will stop the recorder for the time being. I will still be here until 11:50. So if you want to get a head start and actually get started working on this program, this is a good time.